So let's talk about money. So there are lots of things that we talk about in money in general maths, and most of it's involving investment. Okay, so investment is all about interest and whether it's going up, so it's our investment, or whether we're making money by it going up, or whether the bank's making money, so us versus the bank. So the bank makes money when we have a loan, and we make money when we have like a savings account. All right, and so there are a number of ways that we look at interest. And the first and the most basic way is simple interest. So simple interest is taught in year 8, and it is on the formula sheet, and it's just I equals P R N. Now everything has to be the same unit, so if you are talking about years, then your interest rate must be years. If you're talking about months, then your interest rate must be months. The principal is going to stay the same, and the interest is just going to be whatever the interest ends up being. So as long as your two units are the same, then you just multiply the three things together. Now if they ask you for a total at the end, so a total is going to be your principal plus whatever interest that was calculated based on your I equals PRN. Alright, it's fairly basic. The only time that it gets complicated is if they ask you to find, an R or an N or something, or a P. Like they could ask you to find one of these three letters, and then you'd have to rearrange. So let's say our account earned $800 interest when we started with $1,000, and it took 5 years. Okay, so this question they're asking us what the rate is. So to find the rate, you just simplify the other two numbers. So 800 equals 5,000 times R, and divide by 5,000, and 0.16 equals R. And two 5,000s cancel each other out. So that's 16%.
Right.
So that's about the only difficult question you're going to get with simple interest, and that can arise at the end of all sorts of questions. Like it could evolve from something where someone's paying like $500 a week. That's their agreement with Harvey Norman or whatever, and then you have to work out how much they paid in total, take away the principal to work out the interest, and then solve this to work out what the interest rate is that Harvey Norman's charging. Okay, compound interest is also on the formula sheet. Now, it normally looks something like that, but on the formula sheet they use future value, present value 1 plus R to the power of N. So again, your R and your N have to be in the same unit. So if you've got compounding yearly, then you need to power of years. If you're compounding weekly, then you need to the power of weeks. Okay, it's exactly the same. So future value is what it's going to end up being, and present value is now. Okay, just like in English, present value, present tense is now, future value, future tense, what it will end up being in the future. So the main difference between compound interest and simple interest is compound interest, it includes what you've put in. So if we look at something, say we're going to put away $1,000 in the bank at 10% per annum for 4 years. Okay, this will work out to be 1, 4, 6, 4, and 10 cents. So this is what your account will read in 4 years' time.
Yeah.
Okay, that's not how much money you've earned. So your interest that you've actually earned is the amount that ends up being take away what you started with. So the amount minus the principal. So it's going to be 1464.10 minus 1,000, and yeah, 464.10. So compound interest works by compounding what's happening every time. So once the first year goes past and you get interest, it gets added on and they calculate it again, and so on and so on. Whereas simple interest is a once right at the end. Simple interest really isn't how things work in the real world. It's more compound interest. And different banks do it at different times. They compound daily and then pay it monthly and that kind of thing. All sorts of different things. This is the simplified version of what happens in the real world. Okay, so compound interest relates to like simple annuity questions where you've got sort of a timeline where you've got now and the future. And it all revolves around the compound interest formula where the questions are usually something like, Joan wants to go on a holiday in 3 years' time and she needs to have $5,000. Her bank's offering 4% per annum, compounded yearly. We can work out how much money Joan needs to start with. So if she wants to have $5,000, is that a future number or is that a now number?
Future.
A future number. So she wants to have that $5,000 in the future, which is in 3 years' time. So when we put that in the compound interest formula, if we use the FVPV formula, because the future value, it goes over here, and she wants to know what she has to put in the bank today. What we need to do is solve this equation. So this is why there are sort of two versions of this formula on the formula sheet. Now, when we solve this, we're going to divide by that chunk there. And then that whole chunk will cancel out that. And if we do this calculation here, it will tell us what Joan wants or what Joan needs to have in the bank. So she needs pretty much $5,000 today anyway.
Yeah.
Okay, so that's just a one-off payment. So that all comes about from like the other formula on the formula sheet. Looks like that.
Yeah.
So it's either
So it's the same.
like it's the same thing. It's just whether you whether you're talking about like a now number or a future number. So a present value or a future value, and then you put it in the right spot. I mean, you can use that formula, like you can use this formula every time.
Yeah.
And just put in where it goes and then solve it from there, or evaluate from there, whatever you want to do. But the other formula does it straight away, if you're absolutely sure you know which way it should be. Alright, so the last major type are these annuities. So an annuity is a constant investment by you, which is what most people do. So a lot of people have a Christmas account or something like that where they'll put $50 a week in their savings account, and that will happen every week for the whole year. And so they're going to put $50 in 52 times. But because they're putting that money into a bank account, they're getting interest. So the first time they put in their $50, and then they get a little bit of interest. And then in the second week, they have that starting amount and they put in another 50 and they get another little bit of interest. And it keeps going up every time, but it's not a straight line. It's going up by different amounts each time. So we can't use any sort of prediction by a linear model or anything like that. So we used to use this big complicated formula involving those future value and present value formulas, but now we just use the tables. And the tables, they sort of calculate the magic number that it's going up by each time. And it allows us to calculate future values, present values, repayments, all sorts of things. Just depends on the question. So when we work with these annuities, we get given a table, and basically all we have to do is multiply the right number by the amount we're investing. So if we're investing, say, $500 per year, and the interest rate is 3% per year, and we are doing it for the next 10 years. So all we have to do is find the 3%, find the 10, close enough, and where they meet up. So that is this number here, 1146. All right. So all we have to do is multiply our investment of $500. So $500 times 11.46388, and that will tell us how much all of that's worth at the end of that 10-year period, which is 5731.94. So that includes all the lots of $500 that I put in and all the little bits of interest that it gets every year. So if I'm doing $500 for 10 years, that's only $5,000. So this investment has cost me $5,000. That's all I've put in, but I ended up with $5,731.94. So like those little chunks of interest, they're not all the same, because the first year it's 500, then I've got 1,000, then I've got 1,500, then I've got 2,000. So because it goes up every time, the interest changes every time. But at the end of that 10-year period, we end up with an extra $700.31 that we didn't start with. Okay. Okay, so for that last example, it was nice and simple. It was years. But let's say we were doing $500 per month for 10 years at 6% per annum. So with the annuities, they all have to be the same unit. Like every time you do anything with money, it has to be the same unit. And in annuities, it's all based off what you're doing. So if we're doing monthly, then 10 years needs to be months. So how many months are there in 10 years?
120.
120 months. And 6% per annum, if we divide that by 12, we get 0.5% per month. So now we've got months, months, and months. We can do exactly the same thing. So we find 120, which is not on here.
Yeah.
Okay, so this is like a bad example, but you know. Well, let's change it. Let's change it to, what have we got there? Let's say it's 2 years. So then it's 24 months. So 24 months is there, and 0.5% is there. So we find where they meet up, which is 25. So we just do the same thing, 500 times 25.43198. Okay, so they work exactly the same every single time. It's all about finding the right numbers, but it has to be that unit, the magic, whatever it is. Like if it's not all the same, then you're not going to get there. 12,715.99.
Wow.
And so the other tables, the present value tables, they work pretty much the same. Like you just have to find the right number and then multiply it by your payment. So if your present value equals your table times your contribution. So let's say your table number was 17.35284, and you're putting away $200 per month, whatever it is. Doesn't matter. We only use that for that number. So when we work that out, we get 3470.57. So what that means is if you've got the money to start with, you can just put that in the bank. Okay, rather than putting away your $200 every month or whatever it is, if you start with money, you can just chuck that in the bank and it will accumulate to the exact same amount. So if you do your little $200 hops to get to your end, you can just, instead of doing $200 each time, you can just do one big lot of $3,470.57 and end up at exactly the same end point. Mm-hmm. So if you've got money to start with, you don't have to worry about it ever again. And you need less of it. Like if you have more to start with, you need less. But if you don't have it, then obviously you've got to accumulate it. Mm-hmm. So you do use more money, or it costs you more money, I guess, doing it every little jump. But not everyone has a big lump sum to start with. Yeah. But that's what present value is all about in terms of, the tables. But it works exactly the same as the future values. Just find the number, multiply it by the numbers that you're using, whether that be a contribution, so a small amount, or in the future value when you're multiplying it by a bigger amount. Yeah. And so the last thing that's a little bit tricky is to work out, a missing number. So if we know that your future value equals your table times your contribution, okay, and if we're going on a $6,000 holiday, all right, in 3 years' time, and the interest rate's 4%, we would use these two numbers to work out our magic number. Mm-hmm. So let's say that's going to be pen 3.1216. So the future value number is 6,000. The table value is 3.1216. Yep. So we just set that up in an equation. 3.1216 times our contribution and divide by our table number, and that will tell us exactly how much we need to put away each year, I guess, because those numbers are based on years, in order to reach that $6,000 goal. So 1922.09. Okay, so I mean it's almost $2,000, which would, $2,000 a year will get you $6,000, but we're saving ourselves nearly $80 a year, which is not huge, but it's money for nothing. Right. So that's about the most difficult kind of question, is just that working backwards, and that works for all of them. Okay. Working with present value, the future value, it's all just put the numbers in the right spots, whether it's a present value, whether it's a future value or a present value, and get your table number, and then you got to work out your contribution. It's as easy as that. Okay.